Okay, so today we will solve GET 2023 mathematics question. This is question number 17. It is a question from real analysis. What it is saying, for k in n, let ek be a measurable subsets of 0 1 with Lebesgue measure 1 over k square, and E is denote this is intersection from n equals to 1 to infinity union k equals to n to infinity ek, and F, which is union A equals to n equals to 1 to infinity intersection k equals to n to infinity ek, right? Then the two statements are given saying that P, which is Lebesgue measure of E, is equals to 0. For E it is saying that Lebesgue measure is equals to 0, and Q is saying that Lebesgue measure of F is equals to 0. Okay, 4 options are given. Both P, Q are true. Both P and Q are false. P is true, Q is false. Q is true, P and false. Okay, so in order to solving this is the NPTEL reference for this question. Okay, so two sets are given, E and F. You have to say that Lebesgue measure of E and F are 0 or not. Okay, so what it is first given, for k belongs to natural number, ek, these are the Lebesgue measurable subset of 0 1, ek are measurable, and measure of ek, it is saying that 1 by k square, right? And how E is defined? So E is basically intersection n equals to 1 to infinity union k equals to n to infinity ek. And what is F? F is basically union n equals to 1 to infinity intersection k equals to n to infinity ek. So this is basically called the limb soup of ek. So this is limb soup of ek, and this is called limb inf. Okay, we have to find the Lebesgue measure of E and F. So first you have to check that these are Lebesgue measurable. Okay, so let me write one result. So this is one result, that standard result from measure theory, that countable union and countable intersection of measurable sets are again measurable. Right. So what is E? E is basically first we have taken the countable union, then we have taken countable intersection, right? And F is the similarly basically the other way. It is in first we have taken intersection k equals to n to infinity, then we have taken union n equals to 1 to infinity. So therefore E and F are Lebesgue measurable. So now we have to find the Lebesgue measure of E and F. So first let's try for E. So M of E basically this is the Lebesgue measure of E. Lebesgue measure of E. So what is this? So this is basically M of, this is not union, this is intersection n equals to 1 to infinity union k equals to n to infinity ek. right? Now this is basically the intersection, so this you can always write, because as, so note that this is always true, measure of union k equals to n to infinity, because we are taking intersection. So note our intersection n equals to 1 to infinity, union k equals to n to infinity, ek subset of this one, right? Because left hand side we have taken intersection for n equals to 1 to infinity, so when we take the intersection the sets become smaller, right, of this. So this is easily you can check that this is true. So as measure by monotonicity of measure, so this will be true. So this is for all n, right? You can do it for all n. And now what is this? This is just now so here we have used monotonicity, so what is this of m? So it is saying that, so let me write it here. What is monotonicity of m? What it is saying, if E is subset of F, then m of E is less than m of F, right? So this is called the monotonicity of measure. So this is this one, okay. So what we have, m of E, we have got this one. Now there is also one result, subadditivity of measure. What it is saying? So this is, let me write it. If this is m of this countable union, you can write less than equals to sum n equals to 1 to infinity measure of ek. So this is called the subadditivity of measure. Subadditivity of measure. Okay, and this is true for all n, right? Because this does not depend on n. And what is the measure of pk? So this is the k equals to n to infinity 1 by k square, right? So what we have got? So measure of E, so therefore measure of E is less than summation k equals to n to infinity 1 over k square for all n, right? And what is this right hand side? So as summation k equals to 1 to infinity 1 over k square. So this is because this is the you can test that this series is convergent. So n to the power p, where p is bigger than 1. So as this series is convergent, which implies the tail part of this series will goes to 0, which imply for k equals to n to infinity of 1 by k square is goes to 0 as n tends to infinity, right? Means tail part of this series going to 0. So this is the okay. So this is saying that whenever this series is convergent, so this is the tail part of this series will goes to 0, right? So we will use this, that as n tends to infinity the tail part is going to 0. So as measure of E is less than summation k equals to n to infinity 1 by k square for all n. So letting n tends to infinity, what will happen? Right hand side will goes to 0, right? Summation k equals to n to infinity 1 by k square will goes to 0, because this is the tail part of a convergent series, which implies measure of E is 0, right? So you have got that measure of E is 0. Okay, so the first option is basically correct. Lebesgue measure of E is equal to 0. Okay, so this is basically correct. Now let's check the next option. Lebesgue measure of F is equals to 0. Okay, this can be done by similarly. So let's check. What is F? What is F? M of F, basically M of union n equals to 1 to infinity intersection k equals to n to infinity ek, right? So this again by subadditivity what we have done earlier. So this you can write summation n equals to 1 to infinity measure of this intersection ek, right? So this is by subadditivity. Subadditivity of m of this measure. Now what is the measure of this set? You have to find the measure of this set. Okay, so now here we need one observation. So now note this observation here is crucial, that intersection k equals to n to infinity ek, this is basically subset of all ER for R greater than n, right? So what is this saying? So because this is the intersection from, so like this, so this is first En intersection En plus 1 intersection En plus let me write it in red. So why this is true basically? So this is En intersection En plus 1 intersection En plus 2 intersection dot dot dot. So obviously because this is the intersection, this is a subset of some ER for any ER greater than n, right? Because it will, the whole intersection obviously is subset of any set, right? Any ER greater than n, right? So this is obviously true. So therefore what will happen? So then by, so this is for all R, right? For all R equals greater than equals to n. So this is true for any R. So now what will happen by monotonicity? So from here by monotonicity, measure of this set k from n to infinity ek will be subset of measure of ER, right? And this is for all R greater than equals to n. And what is this measure of this? So this is, sorry, less than, because this is measure. And what is this? This is 1 by R square. Now again as earlier we will take R tends to 0. So take R tends to infinity, because this is true for all R. So we can take R tends to infinity, then what will happen? Then measure of intersection k equals to n to infinity ek will be 0, right? So we have got that in measure of this set is 0. So therefore what will be the measure of m? F. Therefore measure of f, which is basically less than measure n equals to 1 to infinity measure of intersection k equals to n to infinity ek, and individually each set has measure 0, so the total is measure 0. So what we have got, M of F has also measure 0. So therefore, what is this option? Q, Lebesgue measure of F is equals to 0. So here both the options are correct. Both P and Q are true and both has Lebesgue measure 0. So therefore both P and Q are true. Option number A is correct. Okay.